One of the most interesting parts of networking with Python is Scapy. This is an interactive packet manipulation tool with which you can capture, decode, analyze, create, and send network packets. Scapy is so flexible that it lets you create any packet you can think of and send it on the wire, even if it is an invalid packet. You can also use it to build network scanners, sniffers, or even attack tools for ARP poisoning or DHCP starvation. Of course, you should build these kinds of utilities for learning and testing purposes only. But enough with the marketing, let's see Scapy in action. The first thing to do is open our GNS3 topology and have router 1 started. Then make sure IP connectivity is established between the virtual machine and R1. So let's do a ping on 192.168.2.101. Okay, great. The second thing to do is open a root terminal and just type in Scapy. If you are running my virtual machine, it will be installed and already available, so enter. You may get some warning messages when starting the utility, but I guarantee there is nothing to be worried about. Scapy will work just fine. First, to see a list of what commands Scapy has available for you, run the lsc function in the Scapy interpreter. So you can see here a long list of commands available for you to use. The next thing to check out in Scapy is the list of networking protocols supported by this tool. You can do this with the ls command, and as you can see, you get a huge list of protocols with which you can play using Scapy. Now let's take this a bit further and see the packet fields and default values for a particular protocol. This can be accomplished by passing a protocol to the ls command. Let's try this for a couple of well-known protocols like, let's say, bootp. Okay, also let's try ICMP or ARP. Okay, so Scapy returns all the fields in the packet and their default values. Cool. Now it's time to sniff some network traffic using Scapy, and the sniff command helps us. Let's go into the Scapy interpreter and simply type in sniff, open and close parentheses. And here we should first specify the network protocol we want to capture, let's say ICMP. We're gonna issue some pings to router R1, so let's type in filter equals and in between double quotes ICMP. And then we should also tell it on which interface to listen for packets. In our case, it will be Ethernet 1, so a comma and iFace equals ETH1. Good. Now one more thing, let's assign the result of this sniffing operation to a variable. Let's say packets equals. Okay. As soon as I press enter, notice that the interpreter remains in a suspended state. That means Scapy is now listening for packets. So let's open a Linux shell and ping R1. 192.168.2.101. Okay, I've interrupted the ping. So we have 4 ICMP packets transmitted and 4 ICMP packets received. So a total of 8 packets should have been captured by our Scapy sniffer. Let's check this. Let's do a Ctrl+C right here to stop the sniffing process. And let's display the variable to see the results. So packets. Notice there were exactly 8 packets captured, as we expected to be. Great, but the question is how to analyze them. Well, we should first use the show function on our variable to see the packets we captured. So packets.show. Okay, this just got a lot more interesting. We can see the ping packets we sent and received from R1. We can see each echo request and echo reply for each ping we did. Also notice that the packets are numbered starting from 0. This will help us for the next operation. Now, just like accessing an element from a list, you type in the variable name, followed by the index or packet number in between square brackets to see more details for a specific packet. So let's say packets of 2. Okay, so here we have the structure and contents of the ICMP packet, that is the third packet captured by the sniff function, so the packet having the index 2. Now expanding on this, there is another function that helps us analyze a packet, and that is the summary function. Let's apply it to the packet we selected. So packets of 2.summary. This actually returns the layers within our ICMP packet. We can see the Ethernet layer, the IP layer, the ICMP protocol layer, and the source and destination IP addresses, and finally some raw data layer. We can go even deeper in this packet by selecting a specific layer from within the packet. So this is done using an index again. So packets of 2 of 0. This will show you the packet contents starting from the first layer. If you would have typed packets of 2 of 1, this shows you the same packet structure, only starting from the second layer in the packet. Now to go further into a layer in the packet and see a specific value inside that layer, you can do this. Let's say we want to extract only the source IP address in the IP layer. So this one right here. We would type packets of 2 of 1 because we are referring to the IP layer, and the .src from source, and we indeed get the IP address we wanted. This feature will be very useful whenever you want to dig into network packets. Good. We know now how to select a layer from the packet and see its contents, but let's see another way to display the layers and the data in a packet in a nicer format. You can easily do this by applying the show function to the packet you want to analyze. So let's see packets of 2.show. Great, this gives you a lot of information about the packet and its layers. First we have some layer 2 info, like the source and destination MAC addresses. Then we have some layer 3 info, like the protocol, ICMP, then a checksum, and the source and destination IP addresses. Now in the ICMP field, we have the type of ICMP packet, which is echo request, a checksum, a sequence number, and other useful information. Okay, great sniffing capabilities provided by Scapy. Now it's time to create and send a packet into the network. Scapy gives us this chance as well, so we should see how to do it. This is going to be useful also for the DHCP client simulator that we're going to build later in the course. Okay, so Scapy gives us the command method in order to apply it on a packet. This method actually recreates an existing packet, a captured packet, and returns a string that you can edit and that is ready to be passed into a function and sent on the wire. Let's see what I mean. Let's apply the method to our packet, which is an ICMP request. So packets of 2.command. Okay, so this is the string representing the packet we created from the packet we captured. Cool. Now to send this packet on the wire, we first have to pass the string to Python's eval function, this function, which evaluates and interprets a string as code. And then we should assign the result to a variable. So, sorry for that. Let's name our variable echo req for request equals eval of packets of 2.command. Okay, now let's see what functions we have available for sending packets into the network. Let's use the lsc command and identify the functions. So lsc, we should focus on these functions right here, or at least some of them. Notice that Scapy is very flexible about sending and receiving packets, providing a lot of functions to suit our needs. I'm going to use the sendp function to send the packet we created and stored inside variable echo req to the router. But first, to check whether our packet is indeed generated and sent to R1, let's enable ICMP debugging on R1 and see if we get any activity after sending the echo request. So let's type in debug IP ICMP. Okay, packet debugging is on. Finally, let's use the sendP function to send the packet on the desired interface. That would be Ethernet 1. So sendP, type in the variable first, so echo REQ, and separated by a comma, you should specify the interface on which to send the packet. So iFace equals ETH1. Okay, so Scapy informs us that it sent one packet. Let's check R1. Okay, so we see an echo reply being sent from R1. This means that it's received an echo request. Great. We should see that it responded to the destination of 192.168.2.100, which is our virtual machine. Now let's try this one more time. Okay, we should see another debugging message. Okay, so another debugging message has been generated by router R1. Great, it works. Do you see how many features does Scapy provide for packet capturing and manipulation? Based on the concepts we've seen in this lecture, we are going to build a DHCP simulator that sends DHCP discover packets, waits for offers, then sends requests and waits for acknowledgements. It will also support DHCP release packets, so it will be pretty complex, but more on that later. For more information on Scapy, please check the link in the additional section of this lecture.